So in the previous video, we cleared all our concept of work energy theorem, and we understand what is COME, conservation of mechanical energy, and its formula, right? So let's see today's topic. Today's hot topic is how can I do COME maths, right? So to understand this, after reading the question, you have to see what type of forces are given in the question, right? If there is no non-conservative force, non-conservative force, if in the question there is no non-conservative force, then COME, conservation of mechanical energy, will valid. Okay, so many of you can understand what is conservative force and what is non-conservative force, but you have to remember this, which one you should call conservative force and which one you shouldn't call conservative force, right? So this is the examples of conservative force: gravitation, spring force, and electrostatic force. And non-conservative force is friction, tension, and air resistance. Okay, so you have to find in the question that in the question there shouldn't be any friction, there shouldn't be any tension, there shouldn't be any resistance. Then the formula of COME will be valid. Okay, so for an example, let's see this math. Okay, so here I can understand that this is a spring. So here will be a spring force 1, spring force 2, there will be a gravitation force, there will be gravitation, right? So there is no friction is given in the question, or there is no tension given in the question. Okay, so this is clearly a question of COME. Okay, so let's solve this question. So what is the formula of COME? COME initial equals to COME final. So what is COME initial? KE plus U initial is equal to KE plus U final. Okay, so before elongation of this spring, what is the internal energy? The internal energy is 0. Why? Because I suppose this is the reference line, and we all know this, in reference line the U is 0. So and in this question there is no velocity initial or velocity final velocity. So we should take this. The formula of kinetic energy is K is equal to half mv square, right? So in the question there is no initial, no final velocity, so the velocity will be 0, and Ke, ultimately the Ke will be also 0, right? So the Ke will be 0 and U will be also be 0, because it is initial position, it is initial and it is final, right? So in the initial, we can see this initial position, the kinetic energy is 0 and internal energy is 0. So ultimately 0 equals to, here the kinetic energy also will be 0 plus internal energy. So the internal energy will be, let's see, this is mgh, right? This x, the displacement is x, so the gravitational work done of gravitation is mgx, and the displacement is towards downward, so the value will be negative, x will be negative, so ultimately the u will be minus mgx, right? My 0 plus minus mgx, and the spring force, the formula of spring force is half kx square. Okay, half kx square. You have to learn all these, why the spring force formula, work done of spring force is half kx square, why the work done of gravitation equals to mgh, why the value will be minus, because the displacement in towards the negative. Okay, if the displacement is toward the positive, in the upward side, then the value of work done of gravitation will be mgx. So if we solve this, 0 equals to minus mgx plus half kx square. Okay, so what we need now, we need the value of x, right? So half kx square equals to mgx. This is x, again we can divide it, and the value of x will be m by k into 2, but x equals to 2m by k. This will be the elongation point. Okay, so this is how we solve all the questions of COME maths, and this is the main point. If there is no non-conservative force, then the COM will valid, and you have also remember this. The conservative force is gravitation, spring force and electrostatic force, and non-conservative force is friction, tension, air resistance. If in the question these are not given, then the question will be solved with COME formulas. Okay, so this is the today's topic, and I think you all understand very well, and let's study and keep it up, right?